This is Accelerated Geometry, Section 4.6, and the topic for today is CPCTC. So the question is, what the heck is that? The CPCTC conjecture says this: if two triangles are congruent, then corresponding parts of those congruent triangles are also going to be congruent. Notice how I put the letters of each of those important words in red. Corresponding parts of congruent triangles are congruent. CPCTC. So we can always abbreviate this reason in a proof as CPCTC, but it stands for corresponding parts of congruent triangles are congruent. So this is what it says. If somebody tells me that triangle ABC is congruent to triangle LMN, I automatically know 6 equalities. I know angle A equals angle L. Even look at the position of these. I know angle B is equal to angle M. I know angle C is equal to angle N. So I know those 3 pairs of angles are equal. And then I know the sides. AB is equal to LM. BC, that side is equal to side MM. And I know AC is equal to side LN. So it's a pretty powerful conjecture. Once you know triangles are congruent, you know all the corresponding parts of the sides and the angles are all equal to each other. So here is an example of a proof that uses CPCTC. It says you are given that angle A, right here, is equal to angle B, so that's marked. AM is equal to MB. And what we've been doing so far is showing that those 2 triangles, the top and the bottom, are congruent to each other. But today, they ask us to show that side AD is equal to side BC. Now, in order to do that, what I'm going to do is I'm going to do what I have been doing. I'm going to show that the top and the bottom triangles are congruent to each other. Because once they are congruent, then I know that this side AD is going to be equal to its corresponding side BC. So angle A is equal to angle B, that's given. Side AM is equal to side MB, that's given. And then I know angle 1 and angle 2 are equal because vertical angles are equal. Notice how I said the full sentence. I just didn't say because they're vertical angles. I say vertical angles are equal. And now, because I know this angle, this side, and this angle, I know that the 2 triangles, AMD and BMC, are congruent to each other, and the reason is ASA. Now, it's important that I have these lined up correctly. Angle A equals angle B, and M is the same in both of them, which leaves D to be equal to C. So it's important as to how you name those. And now that I know the 2 triangles are congruent, I know all the corresponding parts are equal. So the one I'm going to concentrate on is AD equals BC. And the reason for that now is CPCTC. So I'm going to do one more proof, but I'm going to talk about it in 2 different ways. Sometimes in the book they say, is AE equal to BD? Write a paragraph proof explaining why. Well, paragraph proofs get messy for students and long, and halfway through it, students get all messed up. So I'm going to talk about a paragraph proof, but in the next slide I'm going to show you the more compact paragraph, 2-column proof, which students have an easier time with. So here's what they say. The triangles you can use to show congruence are ABD and BAE, but they're overlapping each other. So they say you can separate these triangles and think of them as together, and sometimes they even color code them. So the paragraph proof says I have to show AE equals BD. So we know that the 2 angles D and E are equal. They're marked equal here and here, so that's a given. And we also know that angle B equals angle A. They have that marked here and here. And also AB equals BA because that's a shared side. See, when I draw this triangle, I'm going on a side of AB. And when I draw this triangle, I have a side of AB. So AB and BA, or AB and AB, are equal to each other because they're the same segment. So the two triangles are congruent by SAA, and therefore AE equals BD because of CPCTC. Now here is a better way of doing that. Here are the givens. So everything that has been marked as equal, we write. So angle ADB equals angle BEA. Angle ABD equals angle BAE. Those were the marked angles. So that was the only thing that was given to us over here. Okay, then we still split these apart so that we can see them better. So I take this triangle here and just move it over here. And I take this triangle here and move it over here. So now I can see them in a separated view, and I can see them still up above where they overlap. Okay, now I start. The thing that is first is this first given. And then we write the second given. And then they share this side AB. So AB equals AB because it's the same segment, the same shared segment. So now this is equal to this. So I have two angles, and a side not between them. So because of two angles and a side not between them, SAA, I can say BAE, so here's BAE, BAE is equal to triangle ABD by SAA, and therefore, because the two triangles are congruent, all their corresponding parts are congruent, and the one I want is this side here, AE, this side, and this side BD. So they are equal to each other by CPCTC. Now, look how nice this is also, because when I name them here, look how A and E were the second and third letter, and over here, BD are also the second and third letter. So all these letters kind of match up nicely. So there is a brief view of CPCTC with two examples. So hopefully that'll be enough to get you through some homework.